This is just like a code update, code assets, things that might be useful to people in the lab. So this will be very short, but this is just like if in case anything's useful, I just wanted to share some recent things. The official title is SLAB Shared Software Repo Code Updates by me, Toby Bell. Okay, some updates on the renderer and on Visor's closed loop controllers. The renderer can now render the moon. If you want to render the moon, this is just like setting a foundation for doing more primary bodies in the renderer. You provide the moon pose in the camera frame and it will be there. Some limitations are that currently the built-in is like a low resolution texture. We did this so that it could be built into any versions of the renderer that are distributed by default. So like if you just have the MEX wrapper or the Python wrapper, you can, without configuring anything, just render like a low resolution version of the moon. But it's a to-do to allow you to like provide a reference to like a high-res file or something if you want high-resolution textures. It's a sphere, no oblateness. We probably should fix that. It's color only, doesn't have any displacement mapping right now, so creators won't be shadowed accurately. We need to fix that as well. It doesn't cast a shadow on Tango. That's a very easy fix, but it needs to be done. And there's no relative brightness calibration against Tango or the stars. So this is just like kind of a placeholder to get the code reference there where we can go in and fix these little things. But at a high level, we can draw the moon in the pictures now. So that's nice. Then the other thing, Visor standalone controllers. This is something that like fell out of some work that Mason and I did recently to do testing of the Visor's controllers. But previously they were all kind of woven into like the monolithic control design for Visors that could do mode switching and do all the things that Visors needed to do. But for the sake of testing, we actually separated them into standalone files for each mode of Visors. So our station keeping that we do in Visors, our ROE transferring with like momentum bounding as a rate of time, like not doing too much maneuvering at once, and the actual observation alignment control once per orbit for Visors. These are all like standalone functions now. So in case, I don't know if you want to either just take a look at them or copy them around, integrate them into other things, you can. In order to test them on their own, we made their interfaces pretty generalizable. So the pattern is that you feed your current state estimate, and this is like an ROE plus covariance matrix, as well as two functions that you can decide how they work, which is just give me a prediction for a future state. So these closed loop controllers will need to, for various time horizons, get a future state. And so you just have to give it a function that it can call to get your version of predicted state. So whatever kind of state representation you're using or propagation process modeling you want to do for your prediction, you just implement that. And then the standby and transfer controllers just need to propagate free motion to do like pseudo state correction for the control solvers. The science mode controller needs two. One of them is the free motion propagation, and the other is a prediction of like, if you were to proceed with your current control plan, what would the state be? And it uses this just to decide when to actually replan or if the current plan is good enough. But the pattern is you just call these in a loop, and then if they return maneuvers to you, they also give you a kind of timer, which is how long you should wait until calling it again. So you could use this in your own loop somewhere, and the controller will say, okay, this is the plan you should use for the next half orbit or orbit and a half, whatever, and you can respect that. And then, yeah, the controllers will either tell you they failed or just to do no action and keep your current plan maneuvers. If you're in science, say it says, oh, no, your current maneuvers are good, or replace your maneuvers, and you can use them that way. So they're aimed to be very kind of generalizable, integratable into different contexts. So they're just functions you call, you pass in your nav, and that's that. Any questions about any of these things? Yes.
So the algorithm here is closed form for the three of them.
You can, okay, yeah, you can go like look inside or read the papers, but no, the control solvers vary between the closed form solver, the convex solver,
and the list stores. Yes. Okay. Yeah. So each of them can implement the three of them.
The transfer and standby are just use the closed form solver.
Yes.
And then the science one uses all three.
Okay.
Or sorry, uses least squares and
convex.
And convex solver.
Yes. Okay. Gotcha.
But those also, you could, if you wanted to, you could make copies of these and kind of swap them out because they have similar interfaces.
Yep. Yeah, I think this is very useful. Thank you.
Any other questions? Yes.
Now that they're dedicated functions on their own, is there still the feature where if one particular solver fails, it falls back onto a secondary solver?
That's just a feature of the science controller.
Okay.
Yeah, but that's just done I mean, that's all done inside, so that's all still done in there. I think the biggest thing to get used to with using these is this kind of design where, you know, these are closed loop solvers, but you have to bring your own loop. And so they just return to you how long should you wait before calling it again. I mean, you can wait however long you want. You can call it faster if you want or shorter, but this is by the nature of the control that this controller is trying to implement, it's expecting you to call it after some time in the future. So you should ideally respect the timer that it gives you.
Okay. Toby, is there reported collision avoidance?
For collision avoidance, that's handled at a higher level. So if you wanted to do
Collision avoidance.
Oh, like the escape controller?
Yeah.
Because that's just like a one-shot plan. There's already a function for that. That's kind of just like a control solver where you give a current state, it gives you a maneuver that would implement the escape that's used in advisors, but you don't ever have to call the controller again because it's not a closed loop control. It's like one shot kind of control. So that one is already pretty easy to integrate into something else.
Is this merged already?
Yeah.
Okay.
What C++ version do you need to be able to pass function handles? No way.
These? Well, okay, so this is all just in the FSW repo, which this is FSW repo is on C++ 17.
17?
Yeah, but I mean, it doesn't have, you could do this in C++ 11.
Sure.
Yes. I mean, this type is something that we just wrote in the FSW repo. It's not like a C++ type, but there's a thing called std function that you can do in C++ 11.
Send letter.
Yeah, but you'd have to slightly patch up the code and stuff. Yeah.
Cool.
Yeah, this is where you can find these if you want to look at them, and they have kind of their own interfaces that you can just get a sense of what is in the config struct for each one as well. That's all.
If